Okay, let's continue to talk about typical physical methods we can study transition metal compound. And here I'm going to talk about electrochemical method. Okay, so the most common one is we call cyclic voltammetry. Okay, cyclic voltammetry. So it's very useful to study the redox property of your transition metal compound. Okay, and typically transition metal compound they are redox active. Okay, for transition metal complex. So in CV study, so here is typical setup on the left side. Okay, so in this setup, so you have a your working electrode here. That's a place you will sense the redox potential of your compound. So I think we use that technique for the lab class. Okay. Then reference is the we have a reference because you will read the redox potential against a reference electrode. And here we have contact electrode. Contact electrode because you want to have a full circuit for this system. So this one will balance electron transfer. If you have transition metal compound plus electron go to um, and reduce the transition metal. Okay, then here you have something most like solvent. Okay, will be oxidized to provide the electron. So you can have a full circuit here. Okay, so in selective voltammetry under this setup, you will see this type of curve. Okay, this type of curve that's a cyclic a voltammogram. So like in this case, if you scan from the minus 200 minus 0.2 volt to the positive direction, so you will see a peak here. Okay, peak here. Then normally that's positive current. When you scan the back, right, you will see another, we call that EPA peak. And then because that's anodic, the peak means PA means anodic peak or potential. And PC means cathodic potential. Okay, so here is the oxidation process. And this one is a reduction process. Okay, so that's used first thing as example. Okay, so that's my favorite compound. Ferrocene, 5-membrane ligand as a sandwich compound. So here is iron 2, right? So when you oxidize it, we suppose that's oxidation for this compound. You minus 1 electron, you are going to make iron 3 plus sandwich compound here. And when you skim back, you can undergo this reduction process. You reduce this iron 3 back to the iron 2 plus. Okay, that's how that works. And the CV cyclic voltammetry is very useful to sense the redox change for your compound. For example, if we add a substituent for the first compound like this one, right? So if we add a methyl group here, okay, methyl group on each side, CH3 group. So you will see the redox potential shift to more positive direction, because when you have this electron donating group, it will make the oxidation easier to occur. So you will see a shift here. So that's for FC methyl, okay, methyl. So that's how you can, you know, use the selective activity to detect the redox property which is affected by the ligand effect, substituency effect here. I think that should be enough to serve this class. Okay, let's move on. Right. So last one, that's the last one technique I'm going to talk about for this class. Okay, we call that X-ray diffraction. X-ray diffraction. Okay. No, by the way, so remember, we talk about electron transfer reaction. Or redox reaction. Okay. So that's a just make a quick comment. So that's how you can use selective temperature.